Section 2.2, multiplication with fractions. Okay, we're going to multiply fractions, reduce fractions to lowest terms, and multiply and reduce fractions to lowest terms. Okay, multiply the procedure, multiply the numerators, multiply the denominators, okay? And b and d cannot equal 0 because remember, if b and d are 0, if we get 0 in the bottom, in the denominator here, it is undefined. So, for example here, 1/2 times 3/7, we'll just multiply the 1 and the 3 together, you get 3, and the 2 and the 7, and you get 14. Simple as that. Don't make it harder than what it is. All right, let's do some examples here. We've got 6/7 times 8/5, or 6/7 from 8/5. So let's go ahead and do this real fast. Remember, that can be rewritten as 6 times 8 and 7 times 5. Well, that's going to equal 48 all over 35. Okay, continuing on. Notice we've got this 4/13 times 3. Well, notice here that 4/13 is also in 3 can be written as 3/1. Okay, which will give us 4 times 3. Okay, 4 times 3 and 13 times 1. Okay, well that's just going to turn into 4 times 3 is 12 and 13 times 1 is 13. Now backtracking real fast, I want you to take a look at something real quick here. Notice we've got this 48/35. Okay, we can also, if we want, notice that this is an improper fraction. If we wanted to, we could turn that into a mixed number. I'm not going to do that right now, but notice because the denominator is, the numerator is larger than the denominator, that is something larger than 1. Okay, let's continue on. Okay, 9/8 times 0. Well, this is straightforward. Anything multiplied by 0 is automatically just going to be 0. The rules do not change. Okay, and continuing on, let's look at this one right here. We have got 4/3 times 5/3 times 2/7. Well, that's the same thing as saying 4 times 5 times 2. Okay, and then 3 times 3 times 7. Okay, well, 4 times 5 is 20, times 2 is going to be 40, 3 times 3 is 9, 9 times 7 is going to be 63. Okay, and that's how we do multiplying of fractions. Okay, let's look at an application real fast, kind of help out a little bit. Okay, in a certain voting district, 3/5 of the eligible voters are actually registered to vote. Of those registered voters, 2/7 are independents. They have no party affiliation. What fraction of the eligible voters are registered independents? Well, to figure this out, it's almost like a percent problem. We haven't got to those yet, but it's like a percent problem. You're seeing what's 2/7 of 3/5. So we're going to multiply. So we come over here, look at it. It kind of explains what it's talking about, but it's 2/7 of 3/5. So we're just going to multiply straight across and get 2 times 3 and then 7 times 5. Well, 3 times 2 is going to be 6. 7 times 5 is going to be 35. Okay, so 6/35 of the voters, okay, are independents. Okay, let's look at some rules. Commutative property of multiplication. Remember, commutative property of multiplication works with fractions as well. It doesn't matter what order I put these in. A/b times c/d is the same thing as c/d times a/b, just as long as you remember this rule right here. Okay, when dealing with fractions, you cannot have a denominator that has a 0. Continuing on, notice associative is the same way. Remember, associative is the one dealing with the parentheses. I can move those parentheses around all I want, and it just keeps the same rule applies. Okay, but once again, big rule. I'm going to harp on that a whole lot. Okay, you cannot have 0 in the denominator. Okay, let's just see the examples of these. Notice the commutative property. 3 times 1 and 4/7 is the same thing. You can flip those around. Okay, if you took away the denominator, this would make a lot of sense. Okay, don't let fractions scare you into thinking the rules change. The rules are still the same. The only difference is now I can't have zeros in the denominator. Okay, same thing here. Remember, just wherever those it's associated, because it depends on where you put the parentheses. When dealing with multiplication, it's the same thing here. Same thing with addition. Okay, and then we can check. So, to reduce a fraction to lowest terms, okay, factor the numerator and the denominator into prime factors. Use the fact that k over k equals 1 and divide out all common factors. Reduced fractions may become all improper fractions. Okay, let's take a look at some. Reduce each fraction to the lowest terms. Okay, first off, let's look at this first one and let's get this guy into prime. We're gonna factor it out. We're gonna prime factor each thing. Well, notice the top, that can just go to 3 times 5. Okay? Well, the bottom here, let's take a look at here. If you're a little bit worried about it, let's put the 20 right here. And notice that we can go to 4 times 5. Well, also, this right here is going to go to 2 times 2. So 2 times 2 times 5 will give me 20. So 2 times 2 times 5. Okay? Then what I can do is come here and notice how I've got 5s on both. Okay? Those reduce out. That's what it meant with that k over k equals 1. Okay? And then let's put everything back together. Let's notice that 3 is going to come across, and 2 times 2. So this will reduce to 3/4. Well, same thing here. Let's look at this next one here. I'll put the 35 up here first. Well, let's remember that 35, 5 times 7, both of those are going to be prime numbers. So my top number is going to be 5 times 7. Well, how about the bottom? Let's do 21 over here. Well, remember 21 is the same thing as 3 times 7. Once again, both of these are prime, so I can go 3 times 7. Here, the 7s are going to reduce out, because remember those reduce out to a 1, and I'm just left with 5/3. Okay? Note that the rules for divisibility quickly indicate that 5 is a factor of 15 and 20, and 35, and 3 is a factor of 21. Okay? So here we go. Let's try some more here. Okay, reduce 8 over 72 to the lowest terms. Okay, so let's come in here and remember that the prime factorization for 8 is the same thing as saying 2 times 2 times 2. Well, let's look at 72. 72 is going to be a little harder, so let's come off to the side over here. Well, without even thinking, I'm going to just divide that by 2. And I'm going to get 2 multiplied by 36. Okay, well that's going to equal 72. Well, how about 36? Well, how about 6 times 6? Okay, I'm going to have to kind of come up here a little bit. Well, how about 6? What gives me 6? Well, how about 3 times 2? And I would get a 3 times 2 on both of these right here. Okay, a 3 there. So if I had to write this out, I'm going to get 2 times 2. I'm going to write that with a dot there. Times 2. Okay, so it takes care of 2, 2, and 2, and then I've got times 3 and times 3. Well, notice what's going to happen here is all my 2's are going to reduce out. Okay, and remember, okay, just because something reduces out on top doesn't mean it's gone. That just reduces to a 1. So we're going to be left with a 1 on top, and then 3 times 3, that's going to be a 9. And so this reduces out to 1 over 9. Knowing this reduces to 1 over 9, look what it says here. Or if you see that 8 is a common factor, notice 8 will go into 72. So you could come in here and divide everything, top and bottom, by 8, and you would get 1 over 9. This is just going to be something you're going to see. It starts becoming natural to start seeing some of the smaller ones. Okay, let's come here and do some more here. Okay, multiply and reduce to lowest terms 15 over 28 times 7 over 9. Okay, what we're going to want to do here is if you prime factorize everything, I'm going to do this 2 different ways, trying to be very kind of concise. First off, you can take the prime factors of both of them. Notice that for 15, that's 3 times 5, and then we're also going to multiply that by 7. Okay, well, looking on the bottom here, notice for the 28, okay, well, 28 is going to be, you can do 4 times 7, which could be 2 times 2, okay, times 7, okay, and then for the 9, you're going to get a 3 times 3. Okay, let's start seeing and looking what looks the same right now. Let's do it in blue. So notice I've got this 3 here, that's the same as that 3. I've got a 7 here, that's the same there, and that's the same there. Okay, do I have anything else that matches? Nope, I've just left with a 5 on top, and then I'm left with a 2, and a 3 on the bottom. So to finish this one off, I would keep the 5 on top, and then I would do 2 times 2 is 4, okay, times 3, and that would be a 12. So this would reduce out to 5/12. The other way to think about this, and I'm going to do it over here, is notice I can kind of look across. I can't look side to side, but I can look up and down. And notice that 7 is a factor of 28. Well, how many times will 7 go into 28? Well, 7 will go into 7 1 time. 7 will go into 28 4 times. Same thing over here. How many times is there any common factor here? Well, there is. Think about 3. Well, what if I do 9 divided by 3? Well, that's just going to be a 3. Well, how about 15 divided by 3? Well, that's going to be a 5. And then notice I've kind of reduced without doing all this. And like I said, this is just another process. I got 5 times 1 is 5. 4 times 3 is 12. Okay, so that's what they usually call like cross-reducing. There's some other terms that you could think of, and you'll see this again. Okay, I'll show you this one more time. So let's look at another example here of this one right here. Okay, multiply, reduce the lowest terms using prime factors. Okay, let's look at the using prime factors. Remember, I can put all these together. So let's rewrite this as, well, the 9 is going to be 3 times 3. How about the 25? Well, we're going to get 5 times 5. And then how about right here? How about 2 times 2 is 4, and then I can multiply that by 11, and that'll give me 44. Okay? One long line here. Okay? Well, how about this 10? Well, how about 2 times 5? Well, for the 32 here, I can do 8 times 4. Okay? Some of these might just pop out. Let's just do 8 times 4. Well, 4 times 8 is 32. This is going to give me 2 times 2. Well, right here I've got 4 times 2, and then I've got a 2 times 2. So 2 times 2 times 2 is 8, times 2 times 2, there you go. So here we'll go 2, 2, 2, 2, 2, okay? And then for 33, notice we can do 3 and 11. Well, that's a lot. So let's go and come here and let's start being very careful and start reducing. I have a 3 on top. Now I need to match a 3 on the bottom. So let's come in here. I found a 3. There's that one, and here's one there. Do I have a 3 here? Do I have another 3 on the bottom? I don't. Okay, I have a 5 here. Do I have one on the bottom? Yes, I do, right there. I have another 5. Do I have another one? I don't. Notice I have 2 2s, so I can get rid of 2 2s on top, and I can also get rid of 2 2s on the bottom. Once again, notice I have an 11 here and an 11 there. So finishing this off, I can come in here and go, okay, well, 3 times 5, that's going to give me a 15. Well, then I'm left with 2 times 2 times 2 times 2. Well, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And so that's going to leave me with 15 over 16. And that right there would be my final answer, and simplified. Okay? Now, mind you, I could have come in here and multiplied the whole way across and done all that kind of stuff and then simplified if I wanted to, but that's, if you decide to do that, have at it. Now let's look at the other way of doing it. Keeping this in the form that they had it, notice is the same problem, but notice here they're cross-reducing. They're coming here and going, okay, what can I get rid of where? Okay, here, look, it looks like they divided everything by 11, okay, which gets to a 4 and a 3, but then they're still reducing. It can be kind of a weird process to get to use this, and we're going to do a lot of questions in these class, but notice, like, they divide, 5 divides both 25 and 10. So they came here and said 25 and 10, let's divide that by 5. Well, that's going to leave a 5 there and a 2 there. Well, how about the 11? Look at the 11. It divides both 44 and 33, leaving a 4 and a 3. But then that 4 and 3, look, that divides into the 32, okay? The 4 divides both 4 and 32. So look, 4 will go to a 1, this 32 will go to an 8. And then notice here, this 9 and this 3. Well, the 3 will go to a 1. This 9 goes to a 3. And then we're left exactly what we were left with up above was going to be 3 times 5. And that gives us the 16. And though you're seeing the 8 here, remember the 8 is just 2 times 2 times 2. Okay? And so that's how you can kind of do the cross multiplication. It's going to get easier for you. The only way to get better at this is by practice. Okay? So if I could do anything right here, okay, practice. Okay, this is going to be an invaluable skill that you're going to have to know, because you won't get full points on chapter test. Or chapter test it probably won't let you, but then assessments you won't get full points. So